We now learn how to divide one complex number by another, and to do that we're going to work through the two examples that we see here. As always, let me start by moving the question to the side. We'll start with the first question, that's that one there, so I'll just write 1. There we go. Now we have to divide 3 minus 4i by 1 plus 2i. And to do that, there's a nice little trick that you have to know. Here it is. We can state that this equals to 3 minus 4i over 1 plus 2i times 1 minus 2i over 1 minus 2i. In other words, I'm multiplying the original fraction we had by a second fraction whose numerator and denominator are both equal to the complex conjugate of 1 plus 2i. And we're allowed to do this because this second fraction, well, it's simply equal to 1. So I'm not changing the original fraction's value in any way. Now that that's said, let's go ahead and calculate this. This equals to 3 minus 4i, written in parentheses, times 1 minus 2i, all of which is written over 1 plus 2i times 1 minus 2i. We now distribute the parentheses on the numerator, so that's equal to 3 times 1 minus 3 times 2i minus 4i times 1 plus 4i times 2i. And that's written over the product of 1 plus 2i and 1 minus 2i. Now remember, when we multiply a complex number by its complex conjugate, it equals to the sum of the square of its real part and the square of its imaginary part. In other words, the denominator becomes 1 squared plus 2 squared. So this equals to 3 times 1, which is 3, minus 3 times 2i, which is 6i, minus 4i times 1, which is 4i, plus 4i times 2i, so that's 8i squared. And all of that's written over 1 squared plus 2 squared, which is equal to 5. Now on the numerator, we use the fact that I squared is equal to negative 1, so that leads us to 3 minus 6i minus 4i minus 8. And that's written over 5. Carrying on with my working in the upper right-hand side here, and gathering like terms, we can state that this equals to 3 minus 8, so that's negative 5, minus 6i minus 4i, which is minus 10i. And all of that is written over 5. And we can see right away here that all of the terms have a common factor, which is 5. So we can go ahead and state that this equals to negative 1 minus 2i. And that's the final answer. And the good news is the trick we've just learned for dividing one complex number by another will always work. Indeed, all we have to do is multiply the fraction we have by a second fraction whose numerator and denominator are equal to the complex conjugate of the denominator of the first fraction. Alright, now that that's said, let's quickly work through the second example. So I'll just write 2. There we go. We have to find 3 plus I divided by negative 2i. Well, again, using the same technique, we can state that that equals to 3 plus I over negative 2i times the second fraction whose numerator and denominator are equal to the complex conjugate of negative 2i. So that would be 2i over 2i. Now multiplying, we find that's equal to 3 plus I in parentheses times 2i over negative 2i times 2i. Distributing this 2i across the parentheses on the numerator leads to 3 times 2i, which is 6i, plus I times 2i, so that's 2i squared. And all of that's written over negative 2i times 2i, which is negative 4i squared. Now using the fact that I squared is equal to negative 1, this equals to 6i minus 2 over negative 4 times negative 1, which is 4. Finally, we can state that that equals to negative 2 over 4 plus 6 over 4 times I, which we could of course simplify and write as negative 1 over 2 plus 3 over 2i. And that's the final answer. And so that's how we can divide one complex number by another. And that's it for this tutorial.